There are several different types of statistical graphs that you need to be familiar with. The first one we're going to look at is a frequency polygon. A frequency polygon uses line segments connected to points located directly above the class midpoints. Your text shows you how to use the calculator to construct a frequency polygon. Notice on the horizontal scale you have your class midpoints, and even though you may not have a frequency of 0 on your frequency distribution, you always want to make sure that you follow the pattern on the horizontal scale and bring it, the beginning and the end, down to 0 for our distribution so that it forms a closed shape. An ogive is a line graph that depicts cumulative frequencies, just as a cumulative frequency distribution lists the cumulative frequencies. The ogive is constructed using the class boundaries or class midpoints for the x values and the cumulative frequencies for the y values. It begins with y equal to 0 at the upper boundary of the first class and ends with the total count at the upper boundary of the last class. Notice this graph is using the cumulative percentage. Generally, you'll see these graphs with a frequency. This one chose to do the cumulative percentage. This is an open shape, and it will always increase because frequencies cumulatively increase. A dot plot consists of a graph in which each data value is plotted as a dot along a scale of values. Dots representing equal values are stacked vertically. So we have a table here, or a dot plot. On our horizontal scale, we have 5, 6, 7, 8, and 9. Above those values, we have dots. Now, we also have dots stacked between the values, which means we can assume between those values we also had some values of 5.5, 6.5, but we had no values of 7.5 or 8.5. So let's write at least 3 of the values displayed on the dot plot. So one of those values would be 5. We had one value that was a 5.5. And then we had 3, because we have 3 dots above the 6, so we had 3 6s. So there's 3 of our 6s, and we'll just write more than at least 3 values. And then right after that, we had 4 dots above 6.5, so then we had several 6.5s, 4 of them actually, and so on and so forth until you list all the values for your dot plot. A stem plot, sometimes called a stem and leaf plot, represents data by separating each value into 2 parts. The stem, which is the leftmost digit in the number, and the leaf, which is the rightmost digit in the number. Note that if the stem and leaf were rotated counterclockwise, it would resemble a histogram. So one of the rows is highlighted. The highlighted row represents what values? So on the left-hand side, we have our left digit. Looking at our highlighted row, we have 4, and then each of those digits on the right-hand side on our highlighted row represents a right-hand digit. So 4 and 2, 4 and 3, 4 and 4, 4 and 6, 4 and 8, 4 and 8, 4 and 9. So that row represented 7 individual values: 42, 43, 44, 46, 48, 48, and 49. The first row with a 1 and a 9 just represents the value 19. The last row represents the value 62. So the next picture is comparing two different sets of data. Those sets of data started with 2 digits, 48, 59, 50, 51, all the way down to 73. And then the last digit of those numbers were placed as your leaves. And on the right hand side we have one data set. On the left hand side we have another data set. It is used to compare those two data sets, and again, if you turn those on their side, you can see, are they approximately normal? Do they have any outliers? Different examples like that. We can see that the one on the right hand side is approximately normal with no major outliers, and then the one on the left hand side is a little less normal because it's not quite symmetric, but it does have some outliers up here at 71 and 73 as well. A Pareto chart is a bar graph for qualitative data with the bars arranged in order according to frequencies, with the tallest bar to the left. The vertical scale can represent frequencies or relative frequencies. Note that the Pareto chart highlights the largest type of travel method by putting it first. That was the largest bar to the left. We always want to highlight the one that has the most by putting it on the left hand side, so you can think largest to smallest for a Pareto chart. Now everyone should be familiar with pie charts. Pie charts are an excellent graphic for displaying quantitative data. In a pie chart, each data category is shown as a piece of the pie proportional in size to its relative frequency. As an example, a category with a relative frequency of 30% should receive 30% of 360 degrees, since a circle makes 360 degrees. So that piece of pie would have 108 degrees of the pie. Now, a type of problem that you might be asked to do with a pie chart is, if 110 people were surveyed, how many preferred pumpkin pie? So we have 110 people being surveyed, and we need to know what is 30% of 110. So we say, what is 30% of 110? And 110 times 0.3 is 33. So 33 people out of the 110 preferred pumpkin pie. A scatter plot, sometimes called a scatter diagram, is a plot of paired XY data values plotted on a Cartesian graph. The data are paired to match each value from one data set, which we label X values, with a corresponding data value from another data set, which we call the Y values. The pattern of the plotted points, if there is one, is helpful in determining whether there is a relationship between the two data sets. You can see that the plot suggests there may be a linear pattern between these two variables in the graph. The text provides instructions for using your calculator to construct a scatter plot. And these graphs that I'm telling you, the text provides instruction. It's just like doing the histogram for the most part, except you'll need to pick a different picture when you go to your stat plot. The data on our graph is wife's age on our vertical axis and husband's age on our horizontal axis. And since everything is grouped in the center and increasing, we can see that there is a linear relationship between those two variables. And the last type of graph that you just need to be familiar with is a time series graph. A time series graph plots data that have been collected over a period of time. The example below illustrates the increase in the number of New Zealand internet domains over time. So it starts in November of 93, ends in February of 96, and you can see that it went from probably about 250 all the way up to 3,078. So that is quite a large increase. Now these time series graphs will show you mostly are things increasing over time, decreasing over time, or do they fluctuate?